Thank you. Hello, hello. So, how many people here? This is really funny because there's a latency in the speaker. That sucks. Okay, I'll try to ignore it somehow. For how long? How many people are using Go for less than 2 years here? Are there any? Cool. Maybe there's a talk for you then. For the rest, it's probably not going to be super exciting, but maybe you'll learn something new. This is the third installment of the series, and the usual spiel, like what I'm doing. I actually changed one thing, and that's the last line that I didn't have there before. And that's for like we celebrated more than 20 years running a sound system. Yes, you're right. I'm not working in Pure Storage anymore. I'm working in Everpure. They changed the name. I do the same stuff still, but different name. Okay, thanks for that. So previously what we were talking about is like project structure, error handling, what the defer is for, and so on. And we'll continue in this theme a little bit, but I want to remind everyone about the core principles. That simplicity is more than anything else. Readability is more important than writability, so to speak. And then convention over configuration, right? Like the best thing is everybody does the same thing. You don't have to think about it. Cool. So today's topic is how many were there last time? How many people saw the last one? Okay, so you know the topic. There's gonna be panics, or like don't panic. It's okay. It's okay. Right. Actually, we start with the errors are values, but obviously not all errors are equal, right? There are some that are like you cannot recover from them. They're like, like what you do if there's no power, right? Like you don't recover, so and you don't return a value. So there are certain places where maybe it is actually useful to panic, like you have no idea what to do, right? So we're going to cover that, and let's start what a panic is. Sorry, that's a definition for humans. So, it's like a, fear, terror, immediate, you're really stressed out, you don't know what to do. It actually very often spreads, right? In Go way, it actually is very similar, that it's a way how you handle, if you can say the word handle, in a situation which you cannot recover from, and it usually breaks everything, right? So it spreads as well. So it's very useful for some things, and there actually is a way how to recover, which is a good news, right? So it's not like end for everything. So there is still a hope in the end. There is a caveat that actually you can call recover, but only in deferred functions. That's why it's after we discuss defer. Cool. So this is how you kind of like write it. I don't know if it's visible. Yeah, cool. I might try to make it bigger. Do in the end, like at the very end, see the code. Yeah, okay. Let me see if I can do something about it. Okay. Okay, I scaled it to 250 and nothing happened, so thank you, Chrome. That didn't help. So you'll have to suffer. Basically, you call panic if there's something that you have no idea how to handle. There's basically no meaningful way to handle it. It's like division by zero. There's the example for the back. In case of division by zero, that's not possible. So you cannot do anything. You cannot even, like, what do you return? You don't return. You have to somehow, it's time for panic basically. But there's also a way how you can recover from that. And that's using the recover and how you basically write it in a defer function. You recover from that and it's all safe, all good. So it is very similar to try catch. anybody like coming from Java world, Python, so on, like, yes, cool. So it feels very similar. Like, hey, you know, like if things are really bad, you throw something and you catch it somewhere else. Sounds good. There are differences though. First is control flow. In case of Java, you basically catch it where you want, you handle it, everything is fine. That's very different. In Go and the panic recover, then where you can catch it, I mentioned it has to be in deferred. What you can catch, or like how granular you can be, and also like what's the use case. So let's cover the control flow. In try catch, you basically write the try block. If anything happens, you catch, and then you proceed further. It's fine. You can basically continue. In case of recover or panic and recover, to be precise, the execution is actually not after the panic. Nothing happens. You jump to the caller. So that's here you resume basically from the caller function. Right, that's a really important difference to have in mind. That you basically whatever you write after panic will never get executed. That's guaranteed. So where you can catch it is easy. In case of Java, you can do anywhere, whatever, any place you can nest it. In our case, it's again always deferred, and I have a detailed part at the very end for the interested why it has to be in deferred. What you can catch, as usual with exceptions, you can say which exceptions you want to handle. The rest is like propagated. You can't really do that easily with recover. You have to go switch type and so on, maybe rethrow or repanic again. It's way more tedious, and it's basically manual work. So that's not very useful. And then the major thing is the philosophical difference in the intended use. I let the AI generate this. So because I wanted to know like what's the statistically most common conceptions on like how this should work, right? The panic recovery is really intended for exceptional states, and when I say exceptional, I mean not in an exception sense, but like truly exceptional, something that you cannot recover from. Basically, there's no meaningful way how to get out of this. It should be fairly rare to use. But there are definitely, and we're going to cover that, very useful places where you should actually do panic and recover. Under general situations, you return an error value. That's the in the exception case, it's usually you throw exception, but here you return an error value and you're good. It's for things like nil pointer states that are like totally, you get to the state that's not, in theory, it's not possible, but apparently you got there. Or like initialization failures and stuff like that. We'll cover this in more detail. Cool. So what are the good use cases to panic? Right, for the first one, I would say is like any initialization where you cannot meaningfully even start. It's time to panic. It's like, hey, I cannot, does not make sense to proceed in any way. That's one. Another one is these programming errors, like I would call it like asserts, like you're calling the API the way that it's not possible to proceed. It's time to panic. Like programmer did an error. It's not expected. It's not the network failure. It's like someone wrote a bad code. It should not actually even run, right? And the third one is like when you get to some state that's shouldn't have happened in the first place, right? It's kind of again like kind of an assert for other things. Could be a state machine that somehow got to a state that should not be in, right? Especially if you model it using strings, maybe someone put the wrong string and you're done. And there's no way how to proceed further. So how actually these panic, how it looks like when it happens? It's very straightforward. How it works is once you hit panic, all the deferred functions will be called. And then eventually, if it reaches main, it will crash. It will basically give you a stack trace and a panic message, and the program stops. Right? See that it goes deferred 2 and deferred 1. Could be important in some cases, the order. And that's all. That's basically how it looks. There are some built-in examples. If you do things wrong, like you index slice out of range, you get a panic, because that's exactly the thing that should never happen. And if it does, there's no meaningful way how to get out of it. Other cases, structures that are initialized, like assigning things to a map that has no capacity. Again, there's nothing to do. Shouldn't have happened. Interestingly, closing an already closed channel is actually panicking. And I think that might be a next topic. I did a talk on like why the channels behave the way they do and why closing an already closed channel will panic, and it has to. There's no other way. And for example, the null pointer reference is another nice example. So now let's get to the practical guide. Right. One important place where it's useful and very common to do is application startup. If you cannot get to the point where the program starts correctly, no point proceeding. Another one is isolating requests. You don't want the server to crash because one request was malformed or something. You can isolate Go routines. That's useful for when you're building complicated pipelines. You don't want the program to crash because one of the steps did something wrong. Kind of similar to the isolating the requests. Asserting this, again, basically guarding against the programming errors, more or less. And then there is a useful pattern for like must helper. Are you anybody familiar with this? Like must something? No? I'll show you how to use it. Very useful. Then how to log and how to convert it to errors when it makes sense. So let's go. Application startup. The most common, I would say, and totally legitimate way to use panics is if you cannot meaningfully start. If you have like misconfigured, you cannot do anything useful, you don't have a config to read from, or basically it doesn't make sense to proceed, you cannot parse, whatever, that's the best way to panic. In most cases, this will lead to crash, but at least whoever is calling it will have a chance to look at what happened. This is kind of a canonical way, like simplified, how to do it. Request isolation. That's actually used if you look at an HTTP server in Go in the net HTTP library, standard library. It's exactly what's being done there. So every request, actually the handler function is wrapped in a recover. So if the request for whatever reason panics, which can happen, there's like a ton of stuff, right, being processed. There's many reasons for this to break. It will basically recover, move on. One request broken, it's fine, no big deal, move on. That's what you should aim for. If you're writing a server that doesn't do this, you're doing it wrong. Then protecting from rogue Go routines. It's very similar. Very often in the servers, the one request is actually handled as one Go routine, so it's the same idea. But in this case, for example, if I'm processing some queue and I read like data that are unrecoverable, doesn't make sense, I'm crashing, yeah, move on. Here, it's not perfect example because this will not restart the loop, right? Like if this Go routine will, in the process queue Go routine dies, it will die. So there is another trick where you make everything in loop, and you know it's a small change to make it work in this like run forever fashion. totally doable. Then asserting, I already mentioned that. It was shown in the state. So this is an example where you can make sure that if you're having somewhere, you're defining some state, some constants or something, and then they get handled somewhere else, you should make sure that you handle all this stuff. And if it's something that you're not expecting, you panic, like this shouldn't have happened. This is a scenario where, like, this is a contrived example, very small, so it's like everything is obvious, but it can easily happen that you are processing something that's actually defined somewhere else, and you forget the state. And if you're not using linters, for example, you may not catch that. This is a way how to do it. It costs you nothing to add the default, like panic. It shouldn't have happened, right? And it can save you some time later. Now, this is the must helper pattern. It's basically using it basically forces. It's very useful for the startup again, or for things where you're initializing, like, oh, something has to, let's say you are using templates and you want to load them, so they have to parse. If they don't, there's no way to proceed. The trick is it's basically generics. Very useful way how to use generics here. And it basically transforms from error to panic. Very simple. It's a wrapper. Whatever returns error, if you want to panic on the error because it doesn't make sense to proceed, like in these cases, that's how to do it. Now, one option might be useful is just logging the panics, right? Or you actually log in and you transform it to error, which is the next example I want to show. And here it's like you recover, you print whatever you want to print, and then you panic again with the same thing. It's kind of like rethrow, right? You handle something and then, like, it doesn't have to be logging. You can do way more clever things and then rethrow, or repanic, I guess is better to call it, right? So keep panicking. Cool. Converting to error. This is a very useful thing in cases where you actually want to, and you can see that again in the standard library if you look at how the JSON unmarshalling is happening. Like, if there is how that is done is because it's a recursive parser, if at some point it reaches a point that it cannot parse and therefore the JSON would not be valid, it panics, and then it recovers at the top and returns an error, right? So it's like, oh, you jump all the crap you did. You don't have to pass like 10,000 or however long the stack trace is going to be. You jump to the beginning and say, okay, this is an error. I cannot parse. So this is the way to do it. Now, this is basically the first half of the talk, and like, this is the stuff you should actually remember. It's not all bad, right? Errors are normal. You return error values in that. If it's exception state, you panic. If you can't continue, you crash. It's totally valid approach. And if it actually makes sense somehow to continue, you recover and you make clear on like what are the boundaries you want to go. So that's thanks for the talk, I guess. If you want to hear more, like more details, let me know. We can stop here or we can proceed further. I actually prepared like a second talk, so to speak. Yes, go ahead. We can have questions.
So you showed the panics and I understand the case, but still, why can I just, at the case, I don't know, configuration is failing or missing, I can just throw error.
Yes.
And just the main application will get it and will exit the application with some exit code.
Yeah.
So why use panic here when I can just use regular errors to signalize non-recoverable error?
It depends on how, like, what if it's like 10 functions deep? Like, I don't know how is your configuration done, but like you have to pass all the error, like, oh, if error is this, and it doesn't make sense. Like the only thing you will do is print out and crash or exit.
Yeah, but I mean, I could
Mhm.
maybe wrap the errors. So, and for example, in logs, I need to have it still, let's say, structuralized in JSON. So I
Okay.
can see it in Elastic and it's like wrap, and I can then follow through the wraps, like it happened this. Because when it prints the stack trace, it will break the logging of Elastic because it's multi-line and it's no longer like in JSON encoded. So, and it also feels harder to test. I don't know how would I like unit test the panic and if the recover was called.
I think like if you're testing for panic, you're like testing a state that should not ever happened. It's
But
like,
I guess
are you testing for division by zero?
no. I mean, I guess I understand the built-in panics. I
Yes.
see the reason there, but I don't know why would I panic voluntary in my application because for example, I want to test that somebody forgot to input the parameter, and I know how my application will behave if the error is actually responded when I wanted to error. So,
So in that case, you probably what you want is a recover at some point and have a nice printout, log, everything, but you don't have to worry and carry on and pass the error like through I don't know how many functions.
yeah. I mean,
It's similar to the JSON parsing problem.
I see.
Right, because if you use JSON or marshalling and there is an error, you get an error. You don't get a panic, right?
Yes,
and
yes.
and the magic is that actually internally it uses panic, but then it jumps at the top, recovers, says like, okay, there's an error. It takes the message, it takes the text from the panic and translates it and creates an error and returns an error. Right. So this is the trick you can do.
Yeah. Okay.
So it's a shortcut, so to speak.
Yeah.
Because otherwise you would, for example, in JSON, you would, I don't know how long you would have to return, and all the time error, when you know that it actually doesn't make sense to proceed. So it's like, oh, let's go back to the beginning.
Okay, yeah.
Does it make sense?
Yeah, a little bit. I just have to internalize it a bit in my head, but it's a different style. Like
Yeah. It's I understand. Like I know in general panics are very discouraged, but I think it's not like there are actually valid use cases, and this is the one.
Okay, thanks.
Right. And maybe I'll, if you want, I can continue with the next talk, so to speak. A quick one, just to describe some like better understanding. Because the thing is that when I was doing this talk, I was digging so deep. I was like, hey, maybe I can do an advanced one a little bit. It's still for beginners, really. It's not super deep, but hey, how actually like this whole thing on a. I'm not gonna go like super detailed in the implementation, but roughly, so if you want to dig deep, you'll understand and have the notion of how things work together. So actually, what happens with when the panic is called, what happens, right, is the Go runtime at that point stops whatever the function it's in. It will stop executing that one. It actually sets a flag. We'll get to that, or set some values on the Go routine, and then goes and runs a deferred function on that function where it panicked. It goes up the stack. We'll go to detail on what the stack is then. For those who, if someone doesn't know, we'll get to that. And it runs deferred function again. It doesn't even bother like what the function was doing. It goes like, oh, I go this function deferred, this function deferred, like basically up to the point until it either crashes because it was main, right, or it recovers. Right, so here's an example. My main process file read data. Something in read data panics. Defer runs for read data. Then defers run for process file, and then for main. Right, whatever was in there, like nobody cares anymore. That's on a high level. Right, there's this unwinding of stack. What that is, actually. Everybody familiar with like how the programs work, stack pointers, stuff like this? Some people not cool. Some people are like maybe. Okay, so just quickly, every function call creates something that's called stack frame, where there's like useful stuff stored, like parameters. It's basically a record in the memory saying this function has been called with these parameters and so on, like arguments and bit of information, right? Local variables are all there and so on. And it goes from bottom to the top. So it starts somewhere. When you call a function, new frame is created, put on the top, saying, "Oh, I'm running this now. The local variables have these values, and so on." And there's also a return address when it's like, "And when this function is finished, you go here." And it goes back, and it actually deletes the whole thing, like it didn't happen, more or less, right? So that's how the function calls get together. Now, in Go, actually, Go routines have their own stacks. It's not just one. Like every single Go routine. That actually means that the important thing, panics don't cross Go routines. So you cannot handle panic that happen in a different Go routine because they don't share stack. That's the important thing. In Go, usually the stacks are very small. That's why you can have so many Go routines and it's not a big deal because they start with very small and they can grow and grow and grow and be pretty large and they need to be. But for short-lived, it basically, a few kilobytes is enough. Cool. Now, defer, like how the defer is implemented, because that for some reason it runs every time, right? It actually is a struct. So there's if you look at this Go source code, there's a struct for Go routine. It's called G. Everywhere you see in the source code of Go runtime, you see G, it means Go routine. And it's a large struct, it has plenty of things. And there is a linked list with what are the functions that should be, what are like a deferred function that should be called, right? So in this case, you add these like three deferred calls. There's a linked list defer and goes, newest is always runs first. So that's why you get always reverse order, then you put them in. And that's how it knows like what to run, right? It actually is a little more complicated because it's for Go routine, so you need to know for which function it was. This is the SP. That's like a shortcut for a stack pointer, like which stack it is for. So whenever some function returns, there is a step which goes, look at the deferred list. If there's anything matching the stack pointer, I'm going to call this, remove it from the list, move on, right? So now I'm assuming that people are making a picture how this actually everything is tied together, right? So in case of panic, now there's on the G struct, on the Go routine, there's also a struct for panic, like and some values in it and so on. At that point, it stops the execution and starts the unwinding the stack, which basically goes only in the stack and return values, and then the deferred list. So it's super fast. It doesn't care what was processed. It just jumps through these two data structures, stack and the linked list. So, and you can see a small example here, runs defers for all the stuff that was like on the charge card and process order, and then it crashes on main because we're done, right? So this is how it ties together. And now recover. What recover does is because now it's obvious why it's always in a defer, right? Because defer is always run, so that's the place. Now, if you do recover, it actually internally goes, and there's like go recover, I think it's called the function internally. Then what it translates to, and it checks like, oh, is this panic still panicking, or how to call it? If yes, it actually sets the recovered to true, so to speak, like, oh, this is recovered, I'm not panicking anymore, it's fine. Then it does its own thing, right, whatever that is, and then it returns because it has a stack pointer, so it knows where to return. That's why it always, like goes back to the caller, and it's fine, right? It returns something, and then it stops and moves like nothing happened. So what it means is like defer, it's always running. Like it's very useful. Like you really use it like as much as you can. You can actually, there's no situation where it's not running, right? Sorry? Okay, yes, of course. Like there are exceptions. Like when it's like operating system deciding that the process stops existing, yes. But otherwise, the deferred always is called. Also, run the recover only where you really is the right place to say like, oh, now it makes sense to actually turn it, for example, to error and move on. Like it's fine, right? It's the shortcut. You can use it really as a shortcut. Like I don't want to deal with in this whole module. I don't want to deal with this. On top, I'm going to return error and it's fine. Important thing, panics don't cross Go routines. If there is a panic in the Go routine that does not have a recover, it will crash the whole thing, the whole program, right? So you have to handle them on the Go routine level. And I guess that's it now, like for real. Yes, thank you. Any questions?